Good morning. Intervertebral disc disease afflicts up to 80% of the adult population in the world. And underlying the changes you see in the MR, which is here, is the significant degradation in its composition, structure, and properties. But the effect of all of this is the severe loss in mechanical competence. That's a direct problem with this joint. And the issue is that current clinical T2 measures cannot be used to indicate the loss in mechanical function of the disc. When you look at this poor elastic, highly hydrated tissue, the interaction between the water and the molecules of this tissue really underline its mechanical response. At the same time, MRI is increasingly being used to probe tissue microstructure or the permeability of water. And therefore, we would like to try and establish whether we can use this protocol to find an association between the spatial distribution of MR diffusivity and the mechanical competence to try and indicate the loss of function as part of degeneration. So what we do, we use human cadaveric spines. We have a various numbers of chambers that allows to mechanically interrogate the joint in the MR. We then try to quantify the performance of this joint using different protocols simulating functional loading, in this case sitting and walking. And from the MR perspective, we currently use T2 relaxations, diffusion gradient, and each one of these protocols is then established at 200 newtons, simulating lying down on the bed, and 500 simulating sitting to try and understand what's going on. To try and establish a more mechanistic rule between the MR and the tissue, we apply high resolution. We then use indentation studies and then especially co-correlate those with biochemistry correlation to try and come up with a material law between the MR and the tissue. So some of our results on the left you see is T2 relaxation maps of a 39-year-old disc with its reference and loaded condition and the corresponding diffusion map. And this is a table summarizing some of our results. Diffusion is able to detect loading, is able to detect differences between tissue. The effect of degeneration and loading, T2R, however, is not able to detect the application of loading, does detect difference in tissues and degenerative state. When looking at single laminar studies, where this is the T2 and these are the diffusivity numbers, we do the indentation study, and what it shows is that the T2 is really not showing a coherent or consistent trend, but the diffusion measures is showing significant and positive correlation with the change in mechanical properties. In this case, it's instantaneous modulus of this material, and these are 3 lamina consistently in the graph. So in thinking about our study, well, obviously we need to try and understand whether this protocol can differentiate the effect of aging, the natural cause of aging, versus degenerative effect. We need to establish a computational model trying to predict what's going on with the disc. And if we are ever to move this to the clinical arena, this being a highly poor elastic history-dependent joint, we need to try and understand which parameters should we use to try and standardize the image, particularly what should we tell the patient to do prior to the imaging, and then try to come up with non-supervised imaging method to allow clinician to do this analysis. These are a list of my collaborators, and that's my information. Thank you very much.